Hey guys, this is an example video of just showing how to do a left, right, and midpoint Riemann sum on 4 subintervals. So this is not an explanation, like a detailed explanation. If you want to see that, I do have another video just going into all the details and just kind of the intuition about it, so just a heads up. So let's just get started on it. So I have chosen kind of a simpler function so that we can really focus on the process of doing a Riemann sum. So I want to compute a Riemann sum on 4 subintervals for 3 plus x on this closed interval. And I want to do the left sum, the right sum, and the midpoint sum. And I'm going to show you how to just kind of get organized so that you can do this. Now, pro tip on this. I highly recommend that before you kind of start the problem, try to actually visualize what it is that you're doing. So here's my actual function. Here's x plus 3. But if I want to look at this on that closed interval, here's kind of the space that I'm trying to estimate the area for, the area above the x-axis. And so what I want to do is I want to start by thinking about what the subintervals are actually going to look like. And why don't we just start this for maybe our left endpoints? So, okay, from green to green, that's kind of the closed interval. So if I think about the 4 subintervals, so they all have to be of the same size. So I'll start there. So there are my 4 subintervals just so I can visualize them. And then I want to think about what does it look like to be on the left endpoint. So I'm going to start here on the left of each subinterval and then just draw over. Starting over on the left in this subinterval and just draw straight over. So I'm just going to continue this pattern all the way over. And then these 4 points, these are the 4 points that I actually need to know. So the other pro tip with this is get yourself organized. So as you're kind of going through and doing this, compile a nice list of all the information that you need. So some of this information that we're going to have for left endpoints, we also need for right endpoints. So this will kind of just help us out. Okay, so this point here, this is 1. The next one is 1.5. This is 2. This is 2.5, and this is 3. So all I need for my left endpoint sum, though, is from 1 to 2.5. So I need 1, I need 1.5, I need 2, and I need 2.5. So these are the values of the function that I need to know. If I plug these into the function, I will get the height of each one of these rectangles. And so I intentionally chose something that would just be simple to calculate because I really just want to focus on the process of these sums. So there's my y values. Okay, so let's maybe table this for a second because I want to talk now about doing the right endpoints. So let's just pivot and look at kind of how this differs. And then I want to show you the 2 tables just so you kind of get a sense of like what I'm saying about we have information that overlaps. So for right endpoints, so here's my graph. So now I have my subintervals already drawn. So I just want to start on the rightmost point of each subinterval. So like I'd start here and then draw over to the other rectangle. And so the fact that you just have to extend it down, that's totally fine. So you want to keep this really strict sense of what this means. So there are your rectangles in this case. So here are the 4 points that I need to know. And so if I just think about, again, if I label this, this is 1, 1.5, 2, 2.5, and 3. So now you can see which values I would need to know for this particular table. So I would actually start at 1.5 because that would be this point right here. So I'd need 1.5, 2, 2.5, and 3. And now you can kind of see what I'm saying about that overlap. So again, these are at least simple to kind of calculate the values of. I'm just plugging them into my function. But, oh, and sorry, this is for my y's. Okay, so you can see how this information overlaps with what we needed for the left endpoints. So I bring this up because when you're kind of coming up with a left, if you have to do both sums, it's probably in your best interest just to compile this all into one table. And then you can kind of see like where you actually need to do the sum. So for the sum, I need the first 4 grid points for the left sum. And then for the right sum, I need the last 4 grid points. So now I've got the table just built with just all the information. So I would just pool your information like this when you have to do a left or a right sum. And so now let's do it. So let's say that I want to do the left sum. So remember, the general idea of this is you are trying to just get the area of each one of these rectangles. So we really just need to get the width times the height for each rectangle. So we know the height now of all of our rectangles. That's what these y values are, but I don't know the width yet. So the width, I've talked about that in another video. We represent that by this delta x. And so I just take the two endpoints and then divide them by the number of intervals that I had. And so this comes out to 1/2 or 0.5. And we could kind of see that just from the graph that we drew. Like this is pretty clearly just going to be 0.5, but just wanted to be nice and thorough. Okay, so I'm going to basically multiply each height by 0.5. So here's in the strictest sense, if I'm trying to sum up all these rectangles. So let's say, like, for instance, just going to this one, so I'm just going to go through like tons and tons of detail here. So if I'm doing my left endpoint sum, so the height of this rectangle is going to be 4 and the width is going to be 0.5. So for this first rectangle, this will be 0.5 times 4. And then for the next rectangle, so we're still working on our left endpoint sum, so if I wanted to do this one, so the height of this particular rectangle, so it's determined by this point here, so this is 4.5. So the width was 0.5 times 4.5. Okay, continuing on. So now I'm going to move on to the next rectangle. So hopefully you're kind of seeing the pattern here. So now I just have to figure out what is the height of this particular rectangle. So it's dictated by this point. So this is the height of 5. So I'm going to have 0.5 because that's still the width times 5. And then for the last one, so here's my last rectangle I'm trying to get the width of. And so basically now I'm just going to take this 5.5 times 0.5. So there's kind of like a really detailed kind of look at how you're summing up all those areas. And just by looking at this calculation, you can see that you can really simplify this if you just have like a couple of points that you're trying to sum up. So I've got 4 and 4.5 and 5.5, oops, 5 and 5.5, sorry, 5 and 5.5. So this is an equivalent calculation, which if you prefer to do it this way, that's totally fine. And if you actually complete this sum, so this comes out to 9.5. And I guess the last thing I really just want to show you with this, so as far as like what points we actually summed up in here, so this was a compiled list of all my left and right endpoints. And I just needed these first 4 for the left. Okay. So that's for the left. So hopefully all that detail and kind of summing up the areas and all that makes sense. So now I want to just pivot to the right. So just to remind you, so here was the graph for the right. So it was these last 4 grid points that we needed. I'm really summing up the same areas. I'm just choosing a different height to do this sum by. So let me go back to my table and clear out all that info. So the one thing I've left up here is that the left sum is just these 4 heights. So now I want to pivot to the right sum. So which heights will I choose this time? It will be these 4, right? And I really get now the structure of this calculation. So I can just take the width and then sum up those heights. So I've kind of explained why I can do this with the left sum. So if I do this calculation, what I get is 10.5. So there's my right sum. So if you have the table in front of you and you have to do a left and right sum, it just makes kind of compiling the information and getting through it go a lot faster. So now we have one more sum to talk about. So we have to now talk about using the midpoints. So here I am at the same kind of, I've got all my intervals. So how do I get to my midpoints? So I literally come in the middle of that interval and then I come up and that's what's going to dictate where my height is. So it's somewhere in between, so midpoint. So if I just kind of continue this all the way up so you can see how this will work. Okay, so there's kind of the visual of what's going on. So you have to just figure out what are these midpoints. So in this case, so the midpoint between 1 and 1.5 would be, this midpoint is 1.25. And then this next point here, so the midpoint between 1.5 and 2, this would be 1.75, and so on. So, okay, let's just write down what those midpoints are. So we said 1.25, 1.75, then the next one would be 2.25, and then 2.75. And so here are my y values that go with this. And so with midpoints, so you've got now all the information that you really need to do this. So let's just go ahead and do the sum now. So this is still the same idea, doing now my midpoint sum. And my width is still the same, so I just have these different heights. So I can still use the same structure of this calculation. So taking this 4.25 and 4.75 and 5.25 and 5.75 and just multiplying all of those heights by the width. And if you do that, then your midpoint sum will come out to 10. And that actually makes sense if you kind of compare these graphs. So if I go back to my original left sum, so this was a little too small, right? So if I look at what my left sum was, my left sum came out to 9.5. And then my right sum, when I did my right sum, when I look at the picture, so just visually I can see this is going to be too high from these 4 intervals. And my right sum came out to 10.5. And then if I look at my midpoint sum, so that should be somewhere in between, which is exactly what it was, right? It came out to 10. So having the picture in front of you so you can compare the sums, I think is a really helpful tool when you're getting used to this. So this is kind of like doing these Riemann sums and having to draw this out. This is kind of a rite of passage in some ways, and it really helps you to understand where we're going with integrals. So I know sometimes it can seem like a pain, but you really got to kind of understand some of these finer details and how the structure of these sums work to get where we go a little bit later. So that's part of why we do that. So that'll do it for this example. Hopefully that kind of just shows you the structure of how these work. But I do have other videos and explanations and examples, so hopefully I'll see you in another one. Thanks for watching.